That's how you say heart, core. 5,000 miles to reach the center. We can't even go 10. But they'll tell you about the inner core and the outer core. The inner mantle and the outer. What in the way? How do you know? Oh, Pastor, you're just ignorant of science. They have ways of knowing. Okay, but how do they know that they're right? How do you test? Look, any device, any measurement has to be calibrated. You can't test anything without first calibrating it. Like, for example, when thermometers were invented, they didn't just draw lines on it and just get, well, this must be this temperature. No, no. You had to calibrate that thermometer. Here's how they'd calibrate a thermometer. They manufacture a thermometer. You know, this is going way back. They make a thermometer, and then guess what they do? They get some water, and they boil it. Okay? And at the point that the water reaches a boil, they can put a line on the thermometer and say, that's 100 degrees Celsius, or that's 212 degrees Fahrenheit. And then they could get some water and get the freezing point. And then they could draw a line on the thermometer and say, okay, this is, you know, 32 degrees Fahrenheit. Who likes Fahrenheit better? So sick of Celsius. You know, speak English. No, I'm just kidding. And get rid of the metric system also while you're at it. I'm just trying to just make every science person mad with this sermon, just every way possible. Nuts to it. So Fahrenheit, you know, 32 degrees, 212 degrees, and then, you know, you might want to put another line on there for the human body temperature. You know, 98, you know, stick it under your tongue. Get the human body temperature, 98.6, right? And I realized this would not be exact, but this would get you in the ballpark, and then you could fill in all the other lines. With those three reference points of, okay, here's 98.6, here's 212, you could then fill in the stuff in between. Okay, but what if I just invented the world's first thermometer? Okay, and I just drew lines on it, and I just said, well, right now it's 54 degrees outside. I said, well, how do you know it's 54 degrees? Well, my thermometer says it's 54 degrees. Okay, but how do you know that that thermometer has anything to do with reality? Because sometimes thermometers are broken and they don't read right. And the way that you'd know is you'd find something where you knew the temperature. I know that this water is 212 degrees because it's boiling. Is everybody understanding what I'm saying? If I have a thermometer, let's say I were to hand you two thermometers and say, one of these are broken. Figure out which one's broken. How would you do it? You know, you'd go somewhere and say, well, okay, I know that this water's boiling. It's 212 degrees. If the thermometer says 212 and you know it's 212, boom, it works. If not, you'll say this thermometer is faulty measurement. You know, you go to the ice water, do the same thing. Go to the human body temperature, do the same thing. Okay, these dating methods of, you know, this is 2,000 years old, this is 500 years old, this is 2,500 years old, the carbon dating. How do they calibrate that? They found objects where they knew how old it is. And they're like, well, we know how old this is. We know this is 50 years old. And then they test it, you know. Or, well, we know this is 1,500 years old. And then we test it. But here's the thing. There's nothing that you can have in your hand and say, well, I know this is 60 million years old. Right. Let's calibrate this thing. Because it's impossible to know that. Do you understand what I'm saying? Yeah. Now, is it possible to know that something's 80 years old? Yeah, you could say, I know this is 80 years old. And then you could test it. And then you know whether your machine is right. Okay, I could get a measuring tape and find something where I know, okay, I know the tiles in my house are 12-inch tiles. And I can see whether my measurement method is right or not. Okay, how in the world can you measure a machine and calibrate a machine that tells you what is underneath the surface of the earth? I mean, think about this, folks. Nobody's ever seen it. Nobody's ever been there. No one has any clue what's down there. Except Bible-believing Christians know that hell is down there. That's all we know. To sit there and say, okay, I'll tell you what percentage of what metal is in that core, is just man professing himself to be wise and becoming a fool. No one knows what's even in the mantle, let alone the core. No one has ever been there. In fact, I read a scientific article. They say they're drilling down to the mantle. It's going to take them like 12 years. It's going to cost billions of dollars. And they don't even know if they're going to make it. And Brother Romero said they're not going to make it. because he used to be in an industry that had to do with drilling and drilling down into the bedrock and into the earth. It's so much harder than anyone can imagine, and it doesn't work. It's probably never going to happen. Okay, so to sit there and say, well, we know what's down there is ludicrous. No one knows what's down there. Okay, the closest thing we could get to it is just trying to piece together the descriptions in the Bible. And you see, if I had that thermometer, how does the thermometer work? The mercury expands and contracts with temperature. Let's say I marked out the 0 line. Let's say we're doing Celsius. Let's say I mark out the 0 and I mark out the 100. You know, the boiling point and the freezing point. And what if I said, okay, now I'm going to use this thermometer to measure things that are negative 500 degrees Celsius. I mean, do I really know that that thermometer is still going to be accurate at those extremes? All I can really tell you, if I've got the freezing point, the boiling point, and the human body temperature, is I can tell you, well, in this range, it's accurate. But guess what? As you start to go to really hot temperatures, that thermometer might cease to be accurate. Because what's going to happen? The chemical can only expand so much. The thermometer is going to blow its top. Okay? Or it can only contract so small. And it might begin to expand or contract at different rates when you get to extremes. So therefore, we can only use that thermometer to measure known temperatures because it's been calibrated. Okay?